Alright folks, here we are again. Same problem pretty much, except one difference. So if we look, there's a ball, and it gets thrown upward at, and this is going to be your starting speed, at positive 10 meters per second. So it starts at a positive 10 meters per second, right? And how long does it take to get to the highest position? Well, before it asks how long is it in the air if you wait for it to come back. So back then, the final speed, so don't write this down, but this was last time, the final speed would have been negative 10 because it said how long is it going to take for it to come all the way back. That's not the case now. Let's do an eraser here. So now, wow, let's get this down. My brush size was huge. Let's fix this. Alright, so now, and the ink flow is low, that's the problem. Now the speed is 0 meters per second. Why is the final speed 0? Because it says how long does it take to get to the highest position. And that's one of the rules right here. It says, where is it? Boy, what is acceleration? Oh, no, this is not it. These aren't the notes. Where is the notes? The notes are right here. So the notes are here, and it says the highest position. It's glitching out a little bit. Right here. When an object is thrown straight up, that's rule number 4, it reaches its highest point. It's understood that VF is 0. So so now we know that the final speed here is 0. Okay? And then it starts at positive 10. We also know that since anything is thrown up or down or dropped or falls, that A is equal to negative 9.8 meters per second squared. We also know that they threw this thing up, positive 10 meters per second, just second. And then the final speed, because we're waiting for it to get to the top, highest position, it kind of stops for a second, then falls back down. So at that point at the top, it is 0 meters per second, and that's when we want to know how much time that takes. Okay, so if you want to look the equation sheet, it is only, and once again, pause the video if you ever want to, but go ahead and compare. This is the only equation that works, is equation 1. And the equation is final speed is equal to initial speed plus a times t. And if we plug everything in, final speed is 0, positive 10 plus negative 9.8 for your acceleration, because gravity always pulls downward, times t. I'm going to move this 10 over and move it that way, so I'm going to end up with negative 10 is equal to negative 9.8 t divided by negative 9.8 and divided by negative 9.8, and that gets rid of this, and that becomes t is equal to 1.02 seconds. Why is it the same amount of time as last time? Well, they threw it up twice as fast, of course. So last time it took 1.02 seconds to get there and all the way back, but remember, they threw it at 5 meters per second, a lot slower. Here they're throwing it twice as fast, and it takes that long just to get up here. Okay, so that's why, and that's the correct answer, and that's how you solve it. So now you can try some practice problems out to try to solve for time with gravity problems.